Dear students, this is the part 6 of module 2. Today we will discuss about self-assembly of nanoparticles. So in this process, an organized structure, that is a well-shaped ordered aggregates, they are formed from a disordered system of components. Here, the disordered items, they are surfactant molecules. So we can say, due to the local interactions, an aggregate is formed in a solution through the self-assembly of these surfactant molecules. An example is shown here. This is the surfactant molecule. There will be a long chain hydrocarbon. That is, this tail represents carbon-carbon bonds. And it also has a polar head group. For example, that head can be a nitrogen atom with a positive charge. So a surfactant can be triethyl ammonium or ethyl ammonium ion, or just like that. It will have a polar head group and non-polar chain, that is a long tail. When you bring such surfactant molecules, many of such surfactant molecules, and if you put them in water, they will self-assemble. That means they come together and form some kind of an ordered structure. If you check here, these surfactants, they are arranged in ordered manner, and the polar head groups on the periphery and their tails, they are pointing inwards. Okay. So there is particular way of assembly in order to form the aggregate, and this is called micelle. And here the micelle is spherical. This is an example of self-assembly in a solution. So we will get an ordered aggregates, that is from the surfactant molecules within the liquid. And in the last session, we studied about top-down and bottom-up approach. In self-assembly, since we are making nano-sized aggregates from surfactant molecules, from atomic or molecular level, this process will come under bottom-up approach. Okay. You can also note the shape of micelles. It will depend upon the temperature and the concentration of surfactant molecules in the liquid. If the concentration of surfactants, if they are, say, if it is very small number, then there will not be any self-assembly or self-grouping. If we increase the surfactants, there will be self-assembling or self-grouping, and you may get spherical or cylindrical structures. If we further increase the concentration of surfactants, we will get stacked cylindrical structures, or we can say hexagonal phase. If we are again increasing, we will get cubic structures. And at very extreme condition, there is very high concentration of surfactants and very high temperature, we will get lamellar phases. Okay. So we can say the structure of aggregate, it will depend upon the concentration of surfactant molecules and the applied temperature. Now we can see some examples of self-assembled chemical structures. They can be liquid crystals, then self-organized monolayers, trimethyl aggregates, etc. The reason for the self-assembly are, it can be due to the temperature, it can be due to the intermolecular interactions, sometimes it can be due to the non-covalent interactions, that is due to the van der Waals force, electrostatic, or due to the hydrophobic interactions, or maybe due to hydrogen bonds. Okay. So this is an introduction about self-assembly, and we can conclude this introduction session. So in molecular self-assembling, the molecular components, they will reorganize, that is reorganize themselves without any applied force, and they will form an aggregate. These nanoparticles, it will have unique characteristics that can be electrical, mechanical, or optoelectronic properties, and that will be very unique. Please note, the main reasons for self-assembly are the Brownian motion and intermolecular, and also the non-covalent forces. Brownian motion means the random movement of the microscopic particles within the fluid. Okay. In the next class, we can discuss about other processes like grinding with iron balls and other milling processes. Okay. Thank you.